All right, welcome back to the CyMax channel. I'm going to tell you today about the refreshing of my VASP Python ASE interface. I wrote this first maybe 10 years ago, and 3 or 4 years ago decided to mothball it because it had gotten out of sync with ASE and was no longer kind of compatible with state-of-the-art methods in high throughput calculations. And I was kind of prepared to let it go, but Claude Code came along in the last few months, and I decided for fun to see if I could make it current and modern and solve all of the issues that I had before. And so the reason I'm making this video is that was successful beyond my imagination. So there is now a new Python VASP interface that is compatible with ASE and has lots of features that I'll tell you about. In theory, it has support for all of these runners and workflow decorators that are compatible with things like Quack, so that in theory we should be able to use this in high throughput systems. Now, along the way, I was able to do a couple of new things. So it's now going to be pip installable. And if you go to the documentation that is shown up here, then you can find a whole bunch of tutorials that show you how to use it. And it looks like something you should be familiar with. We have some atoms, we create a calculator and run a little script to get the energy here. And so that all should feel pretty familiar to you. So I've made a whole series of tutorials. I'm going to show you a couple of, maybe one or two of them now. So here I have an instance of VS Code, and I have it connected to my Kubernetes cluster at school so I can access some calculations. In the tutorials we have this, getting system information, getting started, relaxation, equations of states. There are about 20-ish tutorials that you can view. And these have all been run, so I'm pretty confident in what they do. And so let me show you some things here. So if I change into the docs, tutorials, results here, Silicon Energy. One of the things that I previously used to do in a directory like this, you can see here we have all of the car files, is I would just type VASP sum, and it would print out here a little bit of information about the formula, the number of atoms, the energy, and so forth. One of the things that I added, it's a separate package from the Python VASP, is a VS Code extension. And so if I click on, say, the POSCAR here, then we get a nice looking POSCAR. If we click on the in-car, you see there's some highlighting. So here I can hover over this and see what is the GGA functional. Here you can click on this and it should open up in to that part of the manual. I find that pretty convenient. And if you click on the out car, this is also kind of highlighted. You see here I didn't use the right number of cores, and so we see in bright red this morning. These also are highlighted, so you can see various information. And if you're familiar with navigation, Command-Shift-O will give me a way to jump to, say, the density of states parameters right here. So that's pretty nice. Going back to the POSCAR, there's a little thing called a code lens up here. And if I click on this, it will open up a little sidebar. I'm just going to close this so we have full screen. And this gives me some nice information, including a view of the crystal structure. And you can repeat these in various ways. You can rotate this, zoom in and out, like so. And then if you wanted to save a PNG of a particular view, And we have a little summary down here of the total energy, etc., the forces, the pressure. You can look at a stress tensor. You could see atomic forces. These ones aren't very interesting. And that's one example. Let's look at one more. Adsorption. Let's do this one and click on Pascal. I'll click on this. Here we get a little bit different, so you can see some of these have X's on them. That means that these atoms are constrained. And so the only one in here that's not constrained is this adsorbate, and we can use this to see. It's kind of hard to see in this tiny screen, but this updates the geometry over here. Anyway, you can find this on the VS Code extensions. It looks like this, VASP sum, here's my name. You can install it here in this particular container, and then you can use this to visualize or interact with the VASP calculations. So I thought that was a pretty useful and pretty interesting new package that brings VS Code and VASP together in a framework that is useful. So you can find both of these packages on GitHub. If you prefer, you can use the GitHub repo here to clone and install it, or you can just install it from the VS Code marketplace. This was 100% vibe engineered with Claude Code, written in TypeScript, and sort of lightly tested in the way that I just showed you. So if you find issues or have ideas for what else it could do, feel free to drop an issue in the GitHub repo. And similarly, if you find problems with the vasp-ase interface, you should also put that in the repository issues here so that I can work on them and get them working. So that's all that's new. I was super impressed with how easy it was to get the VASP Python interface back up to modern standards, and it fixed a lot of the issues that I was not going to be able to either find time or figure out how to solve on my own. And we have a whole set of tutorials that are new. I'm working my way through updating the DFT book for this, so keep an eye out for that as a future video. And in the meantime, I hope you are able to try this and see if it helps you run VASP in a way that suits you. Thanks for listening, and we'll see you next time.